And we're rolling. Good morning, everybody. The last day of school. This is great. Everybody's excited. Put this thing done, make it done for the year. So, kind of a gloomy, rainy day to end up on, but hopefully you guys will have a nice summer. Last little lesson. You guys should have already taken your test or are going to take your Chapter 2, Section 1 through 4 test today. Get that done if you haven't done so. Submit that. And also your Chapter 2, Section 4 review is due this week. There's your final 2 grades of the year. But I did want to talk a little bit about rocketry, because since we always end up the year with rocketry, this leads right into it. Some fun stuff I want to show you today. Some movies we always watch at the end of the year was that Apollo 13. Hopefully you got a chance to watch that. And another one right here, it's in your book. These guys are the Rocket Boys from West Virginia. They got into model rocketry. It's called October Sky. Great book and great movie. I'd recommend you watch it. It's a lot of fun. It's a very entertaining book, and it's a true story about one of them who goes on to work for NASA as a career. But it takes place in the 1950s, and when rocketry was kind of just getting started. So today we're talking about rockets. We looked at this picture already. How a rocket launches, its thrust. We're going to talk a little bit about Newton's laws too, where you've got thrust pushing down and the force of the burning fuel, liquid oxygen, liquid hydrogen, into the pushing thrust upwards on the rocket as well. So it's action force and reaction force. Action force down, reaction force up, and the rocket goes up. Well, how does it orbit? That's what I'm talking about today. How do things orbit? All right, if you go way back to Newton, he had this idea that if you could throw something fast enough, go up on top of a tall mountain or something and throw something fast enough, it would fall farther and farther apart. That's what this is right here demonstrating. You throw a ball farther enough, it's going to curve back down. That's a projectile motion. If you throw it a little bit harder, a little bit faster, it's going to come down farther. And he had the idea that if you could throw something fast enough, he didn't know what that speed would be, it would keep falling around the planet. And that's what an orbit is. The magic number is 17,500 miles an hour for something to go into orbit. And it's literally falling around. Remember the vomit comet, that weightlessness feeling that they got in the plane as it was falling? Well, that's what's going on in anything they send up there that orbits. The International Space Station is literally going 17,500 miles an hour as it falls to the Earth, but the Earth is falling away out from underneath it as it curves out from underneath it, and so it goes into an orbit. Okay. Well, there's some force going on here that your book talks about now. One is centripetal force. See, that's in your book. Centripetal, P-E-T-A-L. Centripetal force is a push. It's a push or a pull that keeps something going in a circle. Okay, it's pulling towards the center of the circle. Okay, so if I have this this ball on a string, there it is. Okay, and I set it in a circle. The string is applying centripetal force to the ball. It's pulling on the ball. Okay, same idea with, this is the moon going around us, and my hand represents the Earth. Centripetal force, gravity, applying centripetal force on the moon, keeping it going around in a circle. Okay, the moon doesn't naturally go in a circle. It's going in a straight line at a constant velocity. Remember, that sounds like Newton's first law. Okay, the moon is traveling a certain speed in a straight line, but Earth's gravity tugs on it and keeps it going around us. Same thing with the sun's gravity, applying centripetal force on the Earth. Okay? If that gravity was suddenly gone, let's get this going in a circle. If that gravity was suddenly gone, okay, let's change direction here. So I don't throw this ball at the camera, I want to throw it out into the street. If gravity suddenly disappeared, okay, or the string breaks, the centripetal force is gone, and the ball just goes off that's pretty nice, in a straight line until some other unbalanced force acts on it. Gravity pulls it back down to the yard here. Centripetal force. Well, what's centrifugal force? They don't mention that in the book, but centrifugal force and centripetal force work together. Centripetal, P-E-T-A-L, is that pull towards center that keeps the ball from flying off. Okay? Centrifugal is not a force. It's a motion away from center. Okay? This ball doesn't want to go around in a circle. Okay? It wants to go in a straight line. That way. Okay? Cars on a, and we call that centrifugal force. Okay? Centrifugal force. It's not a force. You remember those big yellow cheese boxes you used to ride in to and from school? When that bus makes a sharp corner, you go to you're forced to the outside, right? Okay, it's that centrifugal force moving you, because you want to go in a straight line. The bus turns, you kind of keep going straight, but the bus moves out from under you and you end up on the side. Or a car takes a sharp turn, you're forced to the outside. Okay? I'm back. So, centrifugal force sends the object away from center out in a straight line. There's a ride, I'll try to hook you up with a video on this one. A ride at amusement parks are great for centrifugal force and centripetal force. The rotor is an old-time ride, but we still have this around. It's a big round room, and you're standing against the wall, and the ride starts to rotate. The whole ride starts to rotate. You're all facing center, and you're up against this wall. The whole thing starts to rotate. The faster you go, the more centrifugal force sends you to the outside. Okay, and then eventually the floor drops out, and you're kind of suspended because of centrifugal force sending you away from center as you rotate. The centripetal force, what keeps you from flying off in a straight line, is the wall. The wall applying is a push on you. Okay, it could be a pull of gravity on the moon. It can also be a push on you of the wall. Centripetal force by the side of the bus. When that bus makes a turn, you don't go flying off the bus because the wall of the bus applies centripetal force on you. Roller coasters, same thing. Anytime there's a curve or an up and down, okay, centrifugal force wants to send you in a straight line. Okay, so you're on the Millennium Force doing what's that thing do? 90 miles an hour, 92, 95 miles an hour. In that first hard right turn after you go down the big hill, centrifugal force wants to send you straight through that curve. So hopefully Cedar Point will be open. We'll get to ride that this year. When you are going into that straight line and then the track curves, the only thing that keeps you going around that curve is the centripetal force of the track on the wheels of the coaster. The ride wants to go straight ahead. You and all the passengers are down there and the whole roller coaster, all that thousands of pounds of weight want to go straight. Okay? And as a matter of fact, when you're in the downhill steep dive in the Millennium Force, that roller coaster does not want to curve and level out. It wants to go straight into the ground. So think about that next time you're on that coaster. At the top of the hill, this coaster wants to go straight down into the earth. The only thing saving you is that centripetal force of the track pushing you around that curve, and also on that first right-hand curve too, keeping you going safely on the track. So back to the rockets a little bit. Orbiting, centrifugal force on the rocket doesn't want to go straight. Centripetal force of gravity pulling on the International Space Station, keeping it going around us. Let's see, one last demonstration. It's a little cold to do this, but I'm going to do it anyways. I've never had a chance to do this in the classroom because I can't, dump water all over myself in the classroom. So I've got a bucket of water. You've seen this trick probably. This is actual water in here. Okay, there's water. Okay, my hand is going to apply centripetal force, and the handle is applying centripetal force on the bucket to keep it from flying off in a straight line. What's keeping the water in the bucket is if I go fast enough, the water in the bucket is forced to the outside of the circle, centrifugal force. Okay, like I said, I can do this in the classroom, but not what I'm going to do right now. Okay, so what if all of a sudden the motion stops at the top. What's going to pull that water down? Of course, gravity. Gravity's going to pull it down. So we got some centripetal force keeping it going in a circle. Centrifugal force is sending the water to the outside of the circle into the bottom of the bucket, keeping it in there. But if it suddenly stops, oh, that's cool. Did this all for you guys. It was worth it. Gravity pulls it down, takes it over. All right, so I hope you remember this lesson on centrifugal force and centripetal force, and I hope you guys have a great summer. I hated to have to end the year like this, online learning, but you know, it is what it is. From all the 8th grade teachers, we all miss you. We miss being in the classroom with you guys naturally. That's why we got into this business, to be with kids one-on-one and teach you guys. So hopefully you guys have a great summer. Enjoy it. Enjoy your time off, and watch some rocket movies. Read some books. There's some great books out there on rocketry and stuff like that. But have fun out there. Get outside, enjoy the outdoors like I do. Hopefully I've inspired some of you to get out and enjoy the outdoors, get into some activities. And again, from all the 8th grade teachers, have a great summer. We'll miss you. Come back and see us in the fall.